Hey guys, welcome back. We are starting off with I want to say lesson 13, and this is lesson 13's video. I just want to do a brief recap of half reactions and then we'll move on to today's material. So, here we go. So, the do now says write the half reaction for the following reactions. And I gave you this one reaction. First things first, you want to go ahead and assign oxidation numbers or oxidation states. Once you assign oxidation states, this becomes so much easier. So remember, we don't care about the coefficients, we only care about the subscripts. So these little numbers right here. So I always like to start off with the elements that are by themselves because I remember my oxidation rules that says an element by itself has an oxidation state of 0. So here we go, Ng and Na have 0. And then I also gonna go with my second oxidation rule that says if it's in a compound, the total oxidation state is also 0, even though they have a combined oxidation state. So now I'm going to find what Mg and Cl are in MgCl2 and NaCl. So I know that Mg is in group 2 of the periodic table, and group 2 elements all have an oxidation state of +2. So Mg has +2. That means that Cl, to cancel Mg's +2, needs to be a -2. Now, if they were to ask me what is Cl's original oxidation state, I would do -2 divided by 2 equals -1. In the comments, tell me why am I dividing by 2 over here. Go ahead and tell me why I'm dividing by 2. Then, for NaCl, we're going to do the same thing. Because Na is part of group 1's group 1, its oxidation state is going to be a +1. That means Cl has to be a -1. Good job. So, I'm going to focus on the elements that went to 0, because I feel like that's where most of my attention is going to be needed. So, I'm going to go ahead and change my color. So, we are focusing on Na to Na and Mg to Mg. Alright? So, I first need to determine which one is oxidizing and which one is reducing. Remember, if you're still confused on what is oxidizing and what is reducing, create the number line. Have 0 in the middle, 1, 2, 3, and then -1, -2, and -3. If you're becoming more negative, you are reducing. If you're becoming more positive, you are oxidizing. Right? So, when we see Na is going from 0 to +1. So, according to this number line, it is oxidizing. And then Mg, it's going from +2 to 0. So, +2 to 0, it is reducing. It's going toward the reduced side. So, I'm just going to write red here. Alright. So, now that we have that, we're going to write our half reaction. Now, Na, we're going to go from left to right with our half reactions. So, we're going to do the oxidation first, and then we're going to do the reduction next. So, Na on the left has 0, right? That's the oxidation state we gave it. And then Na on the right has a +1. So we're going to go ahead. I'd like to leave a little space because I might have to use that. Na +1. I'm going to do the same thing with magnesium. Magnesium on the left has an oxidation state of +2 or 2+. And then yields on the right side, it has an oxidation state of 0. Now, I'm going to write my electron. So you have the skeleton right now. You just need to finish it up, right? So for you to finish it up, you need to ask yourself, how many electrons were involved for it to go from 0 to +1? Well, I know that 1 electron was involved. So I need to put my electrons in. But I'm going to put my electrons in on the side that has an oxidation state. So Na +1 is going to get the electron. So +1 here. So there it's going to be +1 E minus. Remember, you must include the E minus. If there's no E minus, I don't know if that's an electron. All right, so I know that this is equal. Then, on my reduction side, how many electrons were involved for me to go from Mg2 plus to Mg0? Well, that was 2 electrons, but I'm going to add it to the side that has, obviously, the oxidation state. So it's going to be Mg2 plus the 2 electrons that are involved, so 2E minus. And that is my half reaction. All right, so these are 2 reaction problems that I've given you. Go ahead, pause the videos, and answer these in the comments. And whoever answers it correctly, I will give you extra credit for that. Alright? So go ahead, answer these in the comments. Be the first ones to do it, and I'll check and I'll give you extra credit. If you want to, you can go ahead and send me the answers, and I will go ahead and reward you extra credit for it. So let's go on to what we're doing today. So today we're focusing on spontaneous and non-spontaneous reactions. And for us to do that, we're going to be using table J of the reference table. So first let's go about what spontaneous and non-spontaneous reactions are. So spontaneous reactions occur without adding energy. They happen on their own. They're very lively and active, right? So and a non-spontaneous reaction will not occur. Sorry, a non-spontaneous reaction will not occur without outside energy. So non-spontaneous, you need an outside energy to force the reaction to go to completion. For spontaneous reactions, you don't need an outside energy. The reaction just kind of happens on its own. So how can you differentiate the two based on an actual chemical equation? Very easily. If the single element is more active than the combined element, then it's spontaneous. Let me say that again. If the single element is more active, key word in this is more active than the combined element, then the reaction will be spontaneous. If the single element is less active, another keyword here, than the combined element, the reaction will not be spontaneous. So they're talking about if you have one element that is more active than the other element, then it's going to be spontaneous. If it's not, it's going to be non-spontaneous. Well, how do we figure this out? By using table J, like I just said. So this is table J. It's a little small, I know. Go ahead and turn to table, I think it's page 4 or page 5 of your reference table. But it's there. It's known as the activity series. Now, table J gives you a list of metals and nonmetals, and it kind of has them organized from most active to least active. Right? It has them organized from most active to least active. So that's what that definition meant. If one of the elements is more active than the combined element, then it's spontaneous. If it's not, it's non-spontaneous. The only one thing that I just want to mention before we even get started, go a little deeper into this, is hydrogen, H2, is not a metal, right? It just has metal-like properties, so it's been organized in that category. But hydrogen is not a metal, it's just a non-metal. It even says it right here on the bottom of the table. Alright, so I'm going to give you a couple of examples before we go on to the real examples that I have here. So basically what it's asking is, and I'll give you an example, is can Mg replace Cr? So can Mg replace Cr? Well, let's look. Well, Cr is right here, and Mg is right here. So because according to this, Mg is more active than Cr, Mg can go ahead and replace Cr in our reaction. Let's see this though. We have Sn and Ti, right? Because can Sn replace Ti? Well, Sn is right here, and Ti is right here. So because Ti is more active than Sn, it cannot replace it, meaning this is a no reaction. A no reaction, and it is also a non-spontaneous reaction. right? And this is spontaneous. Right? So that's how this works. So let's go ahead and let's go to the practice problems to help us out. So there's about 6 practice problems. I'm only gonna do about 3 with you, and I think you can figure out the rest on your own. So we have the instruction says complete the following equation by writing the product in the products formed or no reaction. Now, if it's a spontaneous reaction, then the products will be formed. If it's a non-spontaneous reaction, you have a no reaction. So example 1 says you have zinc plus lead chloride. So zinc, we're going to focus on zinc and lead because they give me 2 metals. Now, if they gave me 2 non-metals, I'll be focusing on the non-metal side of the table. But because they gave me 2 metals, I'm going to focus on the metal side of the table. So, basically, I need to say, is zinc more active than Pb to replace it? So, let's go back here. And we have, let's see, zinc is right here. And then Pb is all the way down here. So because zinc is higher than Pb, zinc is able to replace Pb in the reaction. Meaning our products are now zinc chloride, which plus Pb on the side. Because this is a single replacement reaction. Alright? Now let's go to example number 2. Is zinc, we're dealing with zinc again, is zinc powerful enough to replace beryllium? Let's see. Remember, once again, because they're not giving me a non-metal, I'm not focusing on oxygen. If they did, I would focus on it. But because they gave me 2 metals, I'm focusing on my 2 metals. So, zinc is once right here, and Pa is right up here. So because, remember, zinc was supposed to be on top of Ba, but because Ba is on top of zinc, that means that the reaction cannot happen. So we have no reaction. And because we have a no reaction, we can say that this is a non-spontaneous reaction. Non-spontaneous. But because example 1 went to completion and we have products, we can say that this is a spontaneous reaction. Alright, example number 3, our last one. So we have calcium and we have chromium, I believe. Right? Is calcium more active to replace Cr? So we have Ca right here. So calcium right here. And then we have Cr right here. So because Ca is on top of Cr, that means it's more active. So that means Ca can go ahead and replace Cr in the reaction and produce product. So the Ca, our product is going to be CaF2 plus Cr. Alright, let's do one more just to get it out of the way. So, we have example number 4. We have manganese plus nickel sulfide. So, we are focusing on Mn and Ni. Is this a spontaneous reaction or a non-spontaneous reaction? Let's see. So, we have nickels right here, right? And then we have Mn is on top of nickel right there. So, Mn, since Mn is on top of nickel, it can go ahead and replace nickel, making this a spontaneous reaction and also forming product. So our product is going to be MnS plus Ni. Go ahead and do the last 2 example problems. And hopefully this was helpful. If you have any questions, let me know, and I'm here to help you. Watch this video over and over again if you're getting confused at a little bit of the parts, and let me know if you need assistance once again. Alright, have a great day, guys, and I'll see you next time.